We're in Chapter 6 today, 6.1, Ratios. So we have Chapter 6, 7, 8, and 9, so 4 more chapters to go. And this particular lesson, page 449, is talking about expressing ratios as fractions and doing a little bit of application. And so this is some real basic ideas as far as ratios. If you look in the middle of the page, it has a section, or a little bluish or brownish section called definition. A ratio is a comparison between two numbers and is represented as a fraction, where the first number in the ratio is the numerator, the second number of the ratio is the denominator. So what they're basically saying is that if we have a ratio, it's written as a fraction as 1 to 3. 3 being how many we have, 1 meaning how many we're getting. So kind of like when we were talking about fractions before, this is the total. This is 3. So if you divide a pie into 3 pieces, there are 3 pieces and you get one of them. So it's the same way with a ratio. What we're doing in this first bit of stuff in this section is expressing ratios in lowest terms. So if we have a ratio of 16 to 48, and the 2 is the line there, so it's also a division line, 16 divided by 48. When we're dealing with ratios, it's a 2 line, 16 to 48. So for every 48, there are 16. So if we're looking at how many girls are in a class of 48 students, it would be 16 to 48. If we're looking at how many girls there are to boys, there may be 16 girls to 48 boys. So you got to express with some kind of a unit what you're talking about, but that's really all a ratio is just a fraction. Then you're going to take that fraction and you're always going to reduce it. So 16 to 48, you do your product of primes, your factor tree thing, and you find out that 16 and 48 reduces to, well, let's just do it, 2 times 2 times 2 times 2 is our 16, and our 48 factor tree reduces to 2, 24, 2, 12, 2, 6, 2, 3. So we get 2 times 2 times 2 times 2 times 3, and then we divide out and we're left with 1/3. So for example, 1, express the ratio of 16 to 48 as a fraction. You're just going to reduce that to 1/3, and that's what they're going to want for an answer. So if you turn the page, page 450, they're giving us 2 ratios. They're saying we're going to compare 2/3 to 4/9. So actually what they're doing is they're taking 2 fractions and saying here's the ratio, 2/3 to 4/9. In order to reduce this, well, what do you do when you've got 2 fractions? You take the bottom one, turn it upside down, and multiply it. And that being the case, we end up with 18 over 12, which reduces to 3 halves, because 6 goes into both the 18 and the 12 evenly. Then we run into an example such as example 3. And what they're doing with that is they've got 0.08 over 0.12. So we've got a decimal ratio, 0.08 over 0.12. And if you remember, when we were changing these to whole numbers, what we do is we multiply the top number and the bottom number by a number with the same number of zeros that we went over here. So here, to make this a whole number, we'd have to move this decimal over 2. To make this a whole number, we'd have to move this decimal over 2. So we'd multiply this by a 1 with 2 zeros, and this by a 1 with 2 zeros. Now if this had 3 and this had 2, in order to make it a whole number, we'd have to multiply it by a number with 3 zeros. Okay, so that you take the one that has the number furthest to the right of the decimal, and that's how many zeros you're going to multiply both of them by, not just one. Because if you multiply one number times 100, you have to multiply the bottom number by the same number. So that being the case, we end up with 8 over 12, which reduces to 4 over 6, which reduces to 2/3. So like I said before, if this were at 0.008 over 0.12, we would have to, in order to make these whole numbers, we'd have to move the decimal place 1, 2, 3. So we'd have to multiply this times 1 with 3 zeros. And because we multiplied by this by 1,000, it doesn't matter that this only has to go over 2. You still have to multiply it by the same number. And then when you do this, this becomes 80. I'm sorry, it just becomes 8. Let's just start that over there. This becomes 8. And this becomes 120. And then you reduce this down further. So just make sure when you multiply by the exact same number, the top and the bottom. Alright. So let's look at some applications here. Bottom of page 450. During the game, a baseball player makes 12 out of 18. Or a basketball player makes 12 out of 18 free throws. Write the ratio of the number of free throws he makes to the number of free throws he attempts. So there's my fraction. He attempted 18, he made 12. So that's the fraction I want. All we're going to do is reduce that now to, well, 3 goes into 12 4 times, 3 goes into 18 6 times. Okay, that can be further reduced then to 2, 3. So that means that 18 shots, he made 12. It's the same thing as if he were to take 3 shots, he would make 2. If you look at page 451, example 5, we've got a few things we're looking for, so this is going to take just a few minutes to do. We've got a solution of alcohol and water, so let me just write the abbreviations there, alcohol and H2O. And the solution contains 15 milliliters of water, ml, and 5 milliliters of alcohol. 5 milliliters of alcohol. Find the ratio of alcohol to water. Well, alcohol to water. Alcohol we said first, so it's going to go on top. Water is second, so it went on bottom. Alright, so that's alcohol to water. The next one says water to alcohol. So now we're going to flip them around. And remember, you're going to have to reduce these. And then it says water to the total solution. So we've got water. The total solution is the water and the alcohol combined. So that's going to be 20. And then alcohol to total solution. Alcohol is 5. Total solution again, 15 plus 5. And then we would just reduce all those. That's 1/3. That would reduce to 3. This would be 3/4. And this one then would be 1/4. So that's what they're asking for there. Alright, as far as the problem set, I'm going to skip going over anything in the problem set. There really isn't much there that's going to give you any difficulty. Now let me look here as I'm talking. 15 through 18 looks a little tricky, but let me just kind of put that on the board, what they're asking for there. You know, it's just like when we did the fractions earlier, similar to 12. You know, you've got 9 over 5 to 11 over 5. All we did was flip the bottom one upside down and multiply it and then reduce. 15 would be the same way, but we have 2.5 to 3.5. So what you're going to do is you're going to change those to improper fractions first, and then you're going to take this, flip it upside down and multiply. And you end up with 10 over 14, which you'll reduce to 5 over 7 for your answer on that one. So that's the only rough thing there. But if you look at number, let's look at number 23 real quick. 1.2 to 10. Now you're trying to make this all this a whole number, and we have a 1.2. In order to make it a whole number, we have to move this decimal over 1. So that being the case, 1 and 1 0. but we have to do the same thing here. So that leaves us with 12 over 100, and then you reduce that. So make sure you move the decimal place over 1 to give you 12. Alright, that's it for problem set 6.1.